to only write fractions. In the previous several sessions, we have understood fractions by making fractions, by drawing fractions, by saying the names of fractions, by writing the fractions in numerals. We have discussed the concept of a ratio. We have understood about when ratios are equal. We have understood about equivalent fractions. We have talked about and understood that we can write fractions in different ways, as a long form and as a short form. And today we are going to understand the final part of working with fractions better, and that is the concept of cancellation. When we can cancel, when we cannot cancel. This is something that we will understand today by solving some problems. Now you recall that one very important concept was the concept of an equivalent fraction. If I gave you a fraction, then we can write other fractions which are different in numerals but which are equal. So let's start with a problem in equivalent fractions. I'm going to write a fraction on the board, and you have to write a whole bunch of fractions which are equivalent to this fraction. Please write on your slates and show it to the camera. Right. So both Gyanjyoti and Nandita have written a number of fractions which are equivalent to 1 by 2. Now let me take one of those fractions which Gyanjyoti has written. She has said that this is equal to 7 by 14. How did you go from 2 to 14 and from 1 to 7? What did you do?
Multiply.
You multiplied 1 by
7.
And you multiplied 2 by
7.
7. So what you did, I'm going to write it here. You took 1 by 2 and you said that is equal to 1 into 7 divided by 2 into 7. You multiplied both 1 and 2 by 7, and that is equal to 7 by 14. Now I am going to ask the problem in a different way. I am going to give you a fraction now, and you have to reduce it to the lowest equivalent fraction. 1 by 2 is the lowest equivalent fraction, and to go from 7 by 14 to 1 by 2, I can write that as 1 into 7 divided by 2 into 7. And then what do I do? To go from here to 1 by 2, what do I have to do? To go from here to here,
cancel 7 and 7.
Cancel 7 and 7. Right? So that's all there is to understanding about cancellation. But sometimes, while doing cancellation, we have to be a little careful. So now I am going to give you a problem, and you have to tell me what to cancel. Okay? This is the problem. The problem is 60 divided by 45, which I write this as 45 plus 15 divided by, I can write 60 as 45 plus 15. I'm writing 45 here as 30 plus 15. So now, what should I cancel here?
15 and 15, 30.
So let's cancel 15 and 15. Okay. So I cancel 15 and 15. So what is remaining?
45 and 30.
That is 45 upon 30. Okay. I'm putting a question mark here. Now, I am going to write 45 as 30 plus 15, and I am going to write 30 as 15 plus 15. Can I cancel again?
15 and 15.
15 and 15. I cancel 15 and 15. What is remaining?
30 and 15.
That is 30 upon 15. And what is 30 upon 15? Fifteen ones are 15, 15 twos are
30.
30. So this is equal to
2 by 1.
2 by 1. Okay. So here I have, we started with 60 upon 45. 60 upon 45 is equal to 2 by 1. Do that on your calculator. Do 60 upon 45 on your calculator. Do you get 2 by 1? No. So, where have we made a mistake? Have we made a mistake somewhere? I've cancelled 15 and 15 here, I've cancelled 15 and 15 there, and then I got 2 by 1 finally. So, Nandita?
We can't cancel when the operation is addition or subtraction.
Right. Earlier, we cancelled because it was 1 into 7, 2 into 7. 7 was a factor. But here, 15 is not a factor. Here, 15 is something which I've added to 45. It is not a factor. So when they are not factors, you cannot cancel. Okay, that's one thing to keep in mind. Very often, mistakes are made because we see the same number above and below and we cancel it. I'll give you one more example to see how mistakes are made. So this, that's why I put a question mark here. This is not equal. I cannot cancel 15 and 15 here, because here 15 is not a factor. Okay. So now let's look at another example which will make it clear. I look at 5 upon 3 and I say that this is equal to 3 plus 2 upon 1 plus 2. So now can I cancel 2 and 2? No. But if I cancel 2 and 2, let's see what happens. I cancel 2 and 2 and I get that's equal to 3 upon 1. But 5 upon 3 is not 3 upon 1, right? So it is not 3 upon 1. I cannot cancel. This kind of cancellation is not allowed. But if I have (10 upon 6), I can write 10 as 5 into 2. I can write 6 as 3 into 2. Now can I cancel 2 and 2? Now I can cancel 2 and 2, because here 2 is a factor and 2 is a factor here also. Now I can cancel 2 and 2, and this is equal to 5 upon 3. That cancellation is what we are doing when we make equivalent fractions. So in the session going forward, I am going to now give you problems which you have to do on the calculator. And while doing it on the calculator, if we make a mistake, let's understand what we were doing which we should not be doing. So are you ready? Recall the first problem which we will do is, I'm also going to revise a little bit of algebra, because we are going to be using algebra. Everything that we did in the last few sessions, we will be using it, and you have to solve the problem on your calculator. So now let us take x into y. And the first problem is, you take x is equal to 7, y equal to 5, and solve this on your calculator. What do you get?
35.
35. Okay. Now, the next problem is, you take again x into y, take x equal to 3 plus 4 and y equal to 5 minus 4. Do it on your calculator. What answer do you get?
19.
19. Okay. Nandita, what did you get? 19. So, but we know that x, if x is 3 plus 4, then it is equal to 7. And if y is 5 minus 4, that is equal to 1. So x into y should be 7. But by using the calculator carelessly, we got the answer to this problem, x into y, as 19. Okay. So now I want you to repeat the problem, but go to the scientific calculator format where you have brackets. And now for x, we will put 3 plus 4 in the brackets into y will be 5 minus 4 into brackets, and do that on the calculator. What do you get?
7.
Get 7, right? So let's see what we were doing earlier. The calculator is a very fast instrument, but it's not a very smart instrument. Calculator follows certain rules, and if you do not put in the numbers properly with brackets, knowing what to multiply first, what to add first, what to subtract first, which to do first, which to do later. If you are not careful, you can get nonsense as your answer, because we know that 7 into 1 is not 19. Okay, that's nonsense. Let's see what the calculator was doing. Calculator is fast but not smart. This is what we did in the calculator. You took 3 plus 4 into 5 minus 4. Supposing we did this. What the calculator does is it does the multiplication first. So this becomes 3 plus 4 into 5 is 20 minus 4. What is this?
3 plus 20 is 23.
Minus 4?
19.
Okay. So the calculator got 19 as the answer. Because this is what we did carelessly. What we needed to do was this. If we don't put the brackets properly, we will get nonsense as the answer. So keeping in mind where to put the brackets, and whenever you're working with many numbers, always put brackets to be on the safe side. If you know which is the calculation which has to be done first, put a bracket around it to be on the safe side. Okay, let's do some more problems. Okay, now we talked about x into y. Now I'm going to give you a problem of x x upon y. Okay? And now I can also write this as x divided by y. It's the same thing. Now take x equal to 8, y equal to 4. You can do the calculator, or if you don't need the calculator, you can use your mental calculator. So what is the answer?
2.
2. Okay, 8 by 4, 2. The next problem is that instead of x equal to 8 and y equal to 4, do the same problem. X equal to 5 plus 3 and y equal to 3 plus 1. Use the calculator. What answer do you get?
2.
2. You used brackets, so you got the right answer because you used brackets. Do the same calculation without using brackets and see what answer you get. So I will get 5 plus 3 divided by 3 plus 1, and the answer will be
7.
7. So if you are not careful and you don't use brackets, you will get the wrong answer. You will get an answer which is nonsense. Okay? Whether it's multiplication or whether it is division, you have to be careful and make sure you have the brackets in the right place and you are using the brackets properly. If you use brackets, the calculator becomes quite smart and gives you the right answer. Okay, now let's do some revision. On your calculator, solve this problem. 1 divided by 2 divided by 4. What answer do you get?
2.
2. Is that correct? Look at this. Remember we did division. So this is 1 divided by, what is this? 2 by 4?
1 by 2.
Half. So how many times does half go into 1?
2 times.
2 times. So the answer is correct. Okay. Now, I want you to look at this 1 and into 1 upon 2 by 4. This we could also write as 1 upon 2 by 4, right? 1 divided by 2 by 4, I can write it as 1 upon 2 by 4. I want you to look at 1 into 1 upon 2 by 4. Do this on your calculator. What do you get?
2.
You get 2. So, these are different ways of writing the fraction. Let's do one more example. Okay. 1 into 1 upon 1 by 3. What answer do you get?
3.
3. Okay. Now, if you recall, we had, when we did multiplication, we had said that A upon B into C upon D is equal to
A into C upon B into D.
A into C upon B into D. This is just revision. We had done that in our session on multiplication. Okay. So, now let's look at A upon B into C. I can write C as C by 1. So if I write C as C by 1, what is A upon B into C by 1? What is the answer? Gyanjyoti? Look at this. Here A by B into C by D is A into C upon B into D. So A upon B into C upon 1 is?
A into C upon B into 1.
A into C upon B into 1. But what is B into 1?
B.
B. So this is equal to A into C upon B. Okay. So now we are using algebra to understand how to multiply numbers without actually putting numbers. I will now give you another bit of revision. A problem which is again revision. Remember, we did what is 1 divided by A upon B. Remember this from our division problem? Remember, let's do some 1 divided by 1 upon 3 is equal to?
3.
As a fraction, 3 by
1.
3 by 1, right? 1 divided by 1 by 6 is equal to?
6 by 1.
6 by 1. And then we did finally 1 divided by 2 by 3 is equal to?
5 by 1.
1 by 6 is 6 by 1. 1 divided by 2 upon 3 is?
2 by 3 upon 1.
here 1 by 6 gets inverted. So remember this example that we did finally?
2 by 3.
This is 2 by 3. Two by 3 divided by 1 is 2 by 3. What is 1 divided by 2 by 3? Look at this example here, look at this example here.
Three.
3. This one is
6.
6 by 1. Okay. So if I have, let's say, 1 by 2, answer is
2.
2 by 1. But we know that 1 by 2 is the same as 2 by 4. So if I write this as 1 upon 2 by 4,
Two.
answer should be 2 again. But what do I do with 2 by 4?
Divide.
Yes. To go from 1 by 6 to 6 by 1, I inverted. To go from 1 by 3 to 3 by 1, I inverted. So to go from 2 by 4, what do I have to write here as a fraction?
1 by
1
by 2.
1 by 2. This is not 2, this is 2 by 4. If it's 1 upon 1 by 4, what do I get?
4.
4 by 1. If it is 1 upon 2 by 4, what should I get?
2 by 1.
2 by
1.
2 by 1, that's correct. But in terms of 4, I want to do something with this fraction. What is 2 by 1 equal to? 2 by 1, what are the equivalent fractions of 2 by 1?
4 by 2.
4 by 2. So 1 upon 2 by 4 is?
4 by 2.
Okay. So what is 1 upon 2 by 3? Look at this. 1 upon 2 by 4 is 4 by 2. 1 upon 2 by 3 is? Use the same pattern, the same rule. 1 upon 2 by 4 is 4 by 2. How did I go from 2 by 4 to 4 by 2?
Multiply.
No, from 2 by 4, I went to 4 by 2. What did I do? From 1 by 3, I went to 3 by 1. What did I do?
Inverted.
From 1 by 2, I went to 2 by 1. What did I do?
Inverted.
1 by 2 by 4, I went to 4 by 2. What do I do?
Inverted.
So what should I get here?
3 by 2.
3 by 2. Okay. 3 by 2. This is something that we did at the end of the session on division. Okay, we invert when I divide 1 by a fraction, I invert the fraction. Okay, so keep this in mind. This is all revision. We are going to use what we have done earlier: algebra, multiplying fractions, and recall just what we did a few minutes earlier. We know that A into C by D is equal to A into C upon B into D. Now, I want you to look at this fraction, A upon B, and compare it with this fraction, A upon 1 into 1 divided by B. So here, put A equal to 10 b equal to 2. And do this in your calculator. A upon 1 into 1 upon b, A is equal to 10 and b is equal to 2. What answer do you get?
Five.
Jnanjyoti, what answer did you get?
5.
You also got 5? Okay. So if I do this on the calculator, I get the answer as 5. And here, if I take A as 10 and B as 2, so I get 10 by 2, which is equal to 5. So what we see is that A upon B is the same as A upon 1 into 1 upon B. Right? I can write A as A into 1, I can write B as 1 into B, and then I use the formula earlier, which was that A upon B into C upon D equals to A into C upon B into D. And I've used that to write this as A into 1, B is B, 1 into B, and then I just write the other form AC upon BD, A upon 1 into 1 upon B. Okay. So now let me give you a problem which you have to use this. Here for B, first is for A, I'm going to write x upon y. I'm going to take A itself as a fraction. And for B, I'm going to take another fraction, which I will call u upon v. So now use this formula. Where there is A, put x upon y. Where there is B, put u upon v, and show me what you get. Write it, write it. Now you're not doing a calculator, this is algebra. So now for A, I've put A equal to x upon y, and B is equal to u upon v. Write A upon 1. No, now A is x upon y. So wherever there is A, you have to put x upon y. Upon 1 into 1 upon show that to the camera. X upon y upon 1 into 1 upon u upon v. So now I can write this part here as x upon y upon 1 into 1 upon, but b is now u upon v. U upon v. But now recall, again this is something that we had done earlier. 1 upon 2 upon 3 is equal to
3 by 2.
3 upon 2. So 1 upon u upon v is equal to
V by U.
v by u. Okay. So now I can x upon y upon 1 is the same as x upon y into 1 upon u upon v is
V upon U.
into v upon u. And what is this? I'm writing that up here. I'm just writing that up here. X upon y into v upon u, that is Janjoti?
X into V upon
X into v upon
Y into U.
y into u. Okay. So this, now we've got the formula. We've got a new formula, x upon y divided by u upon v. This is a division problem. I have converted it into a multiplication by inverting this fraction. So that is x upon y multiplied by v upon u. Okay. So now let's put numbers. Now that we know the algebra, we know what to do, let us put numbers. Okay? And this is the problem that you have to do. Okay, do it. Use this formula here. You can put this in brackets if you want. You can put this in brackets if you want. You can put this in brackets if you want. You can put this in brackets, and then you get that. Remember, when you go from here, I started out here, x upon y divided by u upon v is equal to show what you've done. Okay. What is 10 into 3?
30.
What is 15 into 2?
20.
15 into 2?
30.
30. So you get 30 upon
30.
which is?
1 upon 1.
Which is 1. Right? So the answer is? (30 upon 30), which is equal to 1 upon 1, which is 1. Okay. Now I am going to write the same thing here. So that is 10 upon 2 into 3 upon 15. But now I can write 10 as a multiplication. What are the factors of 10?
2,
Into?
5.
I can write 10 as 2 into 5 into, this was 3 there, this 2 is there, into 15. What are the factors of 15?
3 into 5.
3 into 5. Now here everything is a factor. So can I cancel? Here and here? Remember, if I have the same number as a factor, I can cancel it. So what can I cancel here?
2 and 2.
2 and 2. What else? When I cancel 2 and 2, I get 1. 2 upon 2 is 1. Okay. What else can I cancel?
3 and 3.
3 and 3. Again I get 1. What else?
Mm,
Look.
5 and 5.
5 and 5. So I get 1 into 1 into 1, which is equal to
1.
1. Okay. So we are using the algebra to convert the problem into multiplication, and then we write the numbers as factors if they have factors, and then we cancel the common factors and we get the answer. So now, are you ready for a more difficult problem which you have to solve in this method? Okay. This is the problem. You have to do it step by step. Before I do this problem, let's do a little practice with factorization. I want to factorize 45. So I can write that as something into something.
9 into 5.
9 into 5. Can I factorize 9?
Yes.
What is 9?
3 into 3.
3 into 3. So this is 3 into 3 into 5. Now I cannot factorize 3 further. I cannot factorize 5 further. So this is known as the prime factorization of 45. Shall we do one more example? Nandita? Factorize 54.
9 into 6,
9 into 6,
which is 3 into 3 into 3 into 2.
which is 3 into 3 into 3 into 2. Okay. So now I am going to give you a problem which you have to solve. Solve this problem. use a fresh slate if you need. We keep that there and use another slate to continue. So now factorize. 90 is
30 into 30.
30 into
30.
90 is 30 into
3.
3. So now you want to factorize now. So you've got 90 into 3, so it is 30 into 3 into
3.
Yeah, so three into 3 upon 2 into 9 into 9 sixes are 54. 9 into 6. Okay. So now you can cancel some things. Write all the prime factors. Take a fresh slate and continue. 30 is what?
10
Into?
3 into 3.
So write the whole thing. 10 into 3 into. You have how many 3s?
2.
30 into 3 into 3. 30 is 10 into 3 into
3.
Do it on the calculator, 30 into 3 into 3, and see what you get.
Mm.
30 into 3 into 3 is 270, right? And what is 10 into 3 into 3?
90.
Are they equal? So you need, what is 10 into 9 into, don't lose your factors. You're looking at the numerator. The numerator is 90 into 3. What have you written there?
10 into 9.
That is?
90.
Where's your 3? So 10 into 9 into 3. Okay, now continue factorizing. Into 2 into, how did you get 2 there? How did you get 2? Okay, so I think we have fractions under our belt. We've understood fractions, but we have a bit of a problem about factorizing. We've forgotten about factorizing. So our next session is going to be about factorizing. That is something that we need to understand very thoroughly. So we will understand factorizing in our next session, and then finally we will come back and do all these problems. The problem that Gyan Jyoti is facing now is not a problem with fractions, it is a problem about factorizing. So we need some practice with factorizing. That's what we will do in the next session. Thank you.